Hey everybody, hope you're having a great day today. If there are any questions from yesterday, make sure you either write them down on the Google Doc or attend one of the open meets that we're having today. Today we're going to talk a little more about solving radical equations. These are going to be a little bit more difficult than the ones that we solved yesterday. So we'll start off with this, which is something that I talked about yesterday. So what's going to happen here is when we're trying to isolate this radical sign, the square root sign, the first thing we have to do is subtract 13 from both sides. And if you do that, you wind up getting the square root of 5n equals negative 10. Well, if I went around solving this, if I didn't notice that I have the square root of something equaling negative, I would have squared both sides, and I would have gotten 5n equals 100, and I would have gotten n equals 20. But that's not the answer, because if you plug that in, you'll notice if you plug in 20, that would be the square root of 100, which is 10, and 13 plus 10 is 23, not 3. So what this is what's called an extraneous solution. Remember, extraneous solutions, they are solutions that mathematically you get, but they're not really answers. So, mathematically you get this as an answer, but it's an extraneous solution. So this, in fact, would have no solution because the only solution we got is extraneous, so that's why the answer is no solution. We should have noticed that at this point when we had the square root of something equals a negative, we should have known that the square root of something can never be negative, so that's why there's no solution at that point. Okay, so if you ever see that, you should know that there's no solutions. For the next one, here, once you get the radical sign isolated, you have to square both sides. So at this point, we'll square both sides. And we get x squared equals x plus 6. Well, how do I go about solving this? For this one, we're going to have to go back to the chapters before this, where we're solving quadratic equations. We want to get this equal to 0, because that's the best method we have. Once we get equal to 0, we can either use the quadratic formula, we could see if it could be factored. So if I was going through the steps of seeing which way I should solve, I would always check to see if I can factor first, because that's pretty quick. If not, if you could solve using square roots, which probably you won't be able to in these problems, but if you have a quadratic, normally you do that. And then after that, if I couldn't, I'd probably just use the quadratic formula. But here, I believe you can factor, because if you think about two numbers that multiply to negative 6 and add to negative 1, well, two numbers that multiply to negative 6 and add to negative 1 would be negative 3 and positive 2. So that means I can factor it to x minus 3 times x plus 2. And equals 0. So the answers are x equals 3 and x equals negative 2. Alright, now, one thing we want to do is we want to plug both of these in to make sure that both of them are answers, because we can get extraneous solutions here. I might plug one of these in, and it might not work into the original problem. So let's first start off with 3. So if I plug in 3, I would get 3 equals square root of 3 plus 6. Okay, so does 3 equal the square root of 9? Well, yes it does, because the square root of 9 is 3. So this one works, that checks out. For negative 2, if I plug in negative 2, I get negative 2 equals the square root of negative 2 plus 6. Well, I can stop right here, because I'm going to have the square root of 4 equals negative 2. There's no square roots that ever equal a negative, so right away at this point I know that there is no solution to this part. So it's not that there's no solution, it's just that your only answer is x equals 3, because x equals negative 2 is an extraneous solution. Okay, so this one is extraneous. It's because mathematically we get it, and it works, but it is not an actual solution to our problem. So it's an extraneous solution. So with these answers, when you get 2, check to see if both of them work. There's a chance that one of them might not. So now we have a problem like this. So we're going to have to square both sides. So at this point we have the radical sign isolated, which is the goal. And once you have the radical sign isolated, you want to square both sides. The left-hand side is going to become 2k plus 15. And the right-hand side, now it's not k squared plus 36. Remember, k plus 6 squared is k plus 6 times k plus 6. At that point, you have to do the FOIL method, or the double distributive property. So you get k squared plus 6k plus 6k plus 36. If you remember the shortcut for squaring a binomial, you can always use that. I'm not sure how many people remember that at this point. So just do it the old way with the squaring, and this is what you'd get here once you combined your like terms. Alright, so we'll get k squared plus 12k plus 36. At this point, we'll get it equal to 0. We'll subtract 2k, and we'll subtract 15 from both sides. And we'll get 0 equals k squared plus 10k plus 21. Alright, so I'll just quickly look. Can I factor? Are there any two numbers that multiply to 21 and add to 10? 7 and 3. So I can factor it. So I'll do that because factoring is the fastest if you can easily factor it. If factoring really isn't working out for you, of course you can use the quadratic formula. That works as well. Just it's going to take a little more time. So I get k equals negative 7 and k equals negative 3. Alright, so now I want to look back at my original to see which one is going to be negative. Now, you'll notice that you have the square root of 2k plus 15 equals k plus 6. So, whatever this is, the square root, this has to be positive, right? If I plug in negative 7 plus 6 is negative 1. I can't have the square root of something equaling negative 1, so this one's going to be extraneous. Let's check out negative 3. Negative 3 plus 6 is 3. So that's how I know that it should work for that one. So I'm going to try this to make sure it works, but I already know this one does not. So let's try negative 3. That would be negative 6 plus 15, which is 9, equals negative 3 plus 6, which is 3. Square root of 9 equals 3. That is true. So this is our answer. And k equals negative 7 is extraneous. Okay, so the only answer is k equals negative 3. So at this point, why don't you try these 3 out? Okay, these are 3 just like the ones we just did. So try these out and press pause. When you're ready, press play, and you'll see the answers come up on the screen. Okay, so for number 8, we're going to square both sides. And we'll get 4 minus 3x equals x squared. I'll bring this stuff over here, so I'll add 3x, I'll subtract 4. I'll rewrite it too, just so this is on the left-hand side, but I'll get x squared plus 3x minus 4 equals 0. Again, we got that from adding 3x to both sides and subtracting 4 from both sides. And I just switched to left and right, which you can do. Are there any two numbers that multiply to negative 4 and add to positive 3? Sure. Positive 4 and negative 1. So that means that x will equal negative 4 and x will equal 1. If I plugged in negative 4, though, I'd have the square root of something equaling negative 4, so that's not going to work. If I plug in 1, I would get the square root of 1 equals 1, which is true, so this is my answer. For this one here, number 9, the first thing I would do is subtract 10 from both sides. and I get the square root of 3m equals -9. Should be an m. Square root of something will never be negative, so I know there's no solution. For number 10, we'll square both sides. If I square p plus 1 squared, I get p squared plus 2p plus 1 equals 7p plus 15. I'll subtract 7p and subtract 15 from both sides to get p squared minus 5p minus 14 equals 0. Now I'll check what two numbers multiply to -14 and add to -5. Well, that would be p minus 7, or -7, and positive 2, p plus 2. So my answers would be p equals 7, and p equals -2. If I plug in -2, I'd have -1 equals the square root of something, which does not work. So my only answer is p equals 7. So that's how you solve these three types of problems. So if you have any questions, either write them down on the Google Doc or attend an open meet today. And otherwise, there is the online textbook practice. All right, guys, enjoy the rest of your day.